and welcome to our next episode of Learning in Lockdown. So today we are looking at game theory. So we're going to go through something that you may well have seen if you're doing some subjects, kind of like psychology or even potentially sociology. Then we're going to go through some other places where it comes up just in general in life, and then we're going to look at how we home it down for economics, where it comes up in the exam, and then we'll kind of do some check-ins and some just-in-case stuff. So game theory is super interesting. It's really good if you're kind of like a puzzle person or if you're just kind of like solving things. It's very much for you. It's definitely an area you can shine on, and it's like a constant favourite of the exam, so it comes up a lot, right? And it kind of comes up in paper 1 and paper 3. We've seen that in the past. We'll have a look at that in a few kind of videos time. So the first kind of example that I've already written out for you here is the prisoner's dilemma. So it's just a classic kind of prisoner's dilemma. And you know, you may well have seen this before, but we're going to go through it and then we're going to build our own. Then we're going to have a look at some other examples. So prisoner's dilemma, you've got two prisoners, here in this case Ghost and Tasha, and they've been caught. They've been caught by the police, and the police know that they've done it wrong. They can convict them, but it would make it a lot easier if they would just, you know, their case would be a lot stronger if they would just admit. So I'm going to kind of go through here like how this works. I'm going to assign the kind of outcomes to colours. So all it is you have the individual person, or in economics the firm, and then you have the choices. In this case, or in all of the cases that you will look at, there will only be two choices and two firms. Now we apply it to an oligopoly. Obviously it's a perfect duopoly because there's only two firms in there, but actually it just kind of analyses this idea of interdependent decision making and why we end up kind of not in price wars. So kind of getting back to this a little bit. So we're going to have Ghost. I'm going to underline Ghost in red so that you can understand the payoff matrix for Ghost in red. And then for Tasha, I'm going to do green so you can understand kind of like how to read one of these matrices. So Ghost and Tasha have the same options. They can either deny, wasn't me, or they can confess, I hold my hands up. And the combination of those decisions leads to certain outcomes. So for instance, if Ghost decides to deny, then there are two potential outcomes that can happen. Either Tasha also denies or she confesses, and her decision dictates what will happen to Ghost in the same way round. So let's start off with the idea of Ghost denying. So if Ghost denies and Tasha also denies, so if they both choose to deny, then we end up here, and Ghost will receive 5 years in prison, right? If Ghost decides to deny and Tasha decides to confess, then Ghost will receive 18 years in prison. And for Tasha, if Ghost decides to deny and she also decides to deny, she also gets 5 years in prison. But if she confesses, if she throws Ghost under the bus, if she kind of, you know, snakes him out, then she only gets 3 years and he gets 18 years, because the police are like, well, we've got loads of info on him, so we can use that, strengthen our case. He gets loads, we'll pat ourselves on the back. So the underlying red is for Ghost and the underlying green is for Tasha. But what happens if Ghost decides to confess? Well, it's the exact same thing. He will receive 3 years and Tasha will receive 18 years in prison because he's throwing her under the bus, right? If they both decide to confess, then Ghost will receive 10 years and Tasha will also receive 10 years because the police are like, well, we've got them both here, right? And therefore we can get them both pretty evenly, get them locked away. So this explains some interdependent decision making, and by that I want you to think about, well, where will these individuals end up? Where will they naturally end up in this decision making matrix? And what I suggest you do is you kind of pause the video and see if you can work out where these will end up. So where they will end up is simply just looking at the outcomes of their decision, right? So for Ghost, let's look at Ghost's decision making. So he knows kind of some of the outcomes here. He might not know the exact years, but he thinks about, well, what is she going to do? And I need to base my decision based really off what she's going to do. So he knows kind of some of the outcomes here. So he has a choice. If Tasha denies, then his outcomes, he needs to make a decision based on her outcome. So he can either have 5 years if she denies, or he could have 3 years if she denies. Well, which one would he rather have? Well, 3 years in prison sounds a lot better than 5 years in prison. So then if she denies, he's going to confess, right? Because he's making a decision between 5 years or 3 years, and 3 years is less and more desirable. Well, what happens if Tasha decides to confess? Well, then he also has the same decisions. So what should he do? Well, if she decides to confess and he decides to deny, then he gets 18 years in prison. It's a very long time. But if she's going to confess and he also confesses, then he gets 10 years in prison. Well, 10 years is a lot better than 18 years. Right? It's far more desirable. So for Ghost, no matter what Tasha decides to do, he's best off confessing, because in each of those scenarios, his outcome for confession is lower than his outcome for deny. Therefore, he will always confess, right? And then if we have a look at Tasha, what are her decisions? Well, for her, we go vertically, right? So she has a choice based on Ghost's decision, right? So if Ghost decides to deny, well then she knows she can either deny or she can confess. Well, if she decides to deny, she gets 5 years, but if she rats him out, she gets 3 years, and 3 is more desirable than 5 years, therefore she will confess if he denies. Well, what if he decides to confess? Well, if he decides to confess, she will get 18 years if she denies, or she will get 10 years if she confesses, right? So, well, which one's best for her there? 18 or 10? 10 is much more desirable. So no matter what Ghost does, she's better off confessing, because 3 years is less than 5 and 10 years is less than 18. So she will always confess, right? It's her best option. It's what we call a dominant strategy, and actually in all of the game theory matrices that you draw over your A-level anyway, probably, I mean definitely not when you get to university if you're studying economics, you will have 2 dominant strategies. You won't have kind of like a weak strategy or a dominant strategy. Both firms will have dominant strategies. So if they're both going to confess, well, where do they end up? Well, they end up in this situation here. That's where they will naturally end up, right? That's kind of naturally where they will end up. And that natural position is what we call tacit collusion, right? Now it's called collusion because they're not making their decision based on their best interest. Their best interest position would be both to deny. They're making the decision based on what they think the other person is going to do. So they are colluding, but they're not colluding kind of overtly. They're colluding kind of naturally. They're kind of colluding based off what they think the other person will do. And that's what we call tacit collusion. So this position here is their tacit collusion. But it's not the best position for them on the matrix, is it? The best position for them on the matrix would be to end up with 5 years each. That's the best combined decision. But what would they have to do to get to that decision? What would have to change about the game for them to end up in that position? Well, it's very simple. What would have to change is they'd be able to talk to each other. They would be able to make an agreement to stick to that position. And if they decided to stick to that position, then that would be what we would call overt collusion, right? So this is overt collusion, a position where they're overtly deciding to pay off the best position for where they are. But there is an incentive here. Can they maintain this position? Well, potentially, but also maybe not, because what can we see here? That there is a huge temptation for either Tasha or Ghost to throw each other under the bus and to actually wrap them out so they can get that 3 rather than that 5, that 3 rather than that 5, and actually end up in one of these positions here. So overt collusion happens, right? We see that, we'll have a look at that a little bit later on when we look at kind of cartels and price fixing. But it's dangerous, it's a weak position, and it's dangerous and it's weak because there's this incentive to break, right? There's an incentive for them to confess on each other. Now, game theory is rife. I think Golden Balls, the TV series from kind of game show from a long time, its entire end game was based on game theory in real life. But we also see it in many places, including in Love Island, right? So I went to stay at one of my friend's house up north to visit her, and she was like, hey, do you mind if I watch Love Island? I was like, that's fine. And I was watching it for the first time, and I was like, this is just game theory. It's just game theory. And that is with Shauna and Callum is a great example of this. So all these people got shoved off into another villa. Is it villa? It's a villa. And you have a decision. So we'll put Callum here, and we'll put Shauna here, and they have a decision to either couple up with somebody new or to stick with the person that they were originally with. So they can either stick or they can couple up with somebody new. So they can either stick, so Shauna had the exact same option, or to couple up with somebody new. Now, and there are some outcomes to this, maybe not necessarily numerical outcomes, but there are some outcomes. And kind of the ploy, I think, really in Love Island, from the gist of it, that I can really see, is that you want to end up a couple. You have to end up a couple to win. A guaranteed couple has a lot more chance of winning than kind of like the risk of having no couple at all. And that's important when we have a look at this game theory matrix. So Callum and Shauna have the decision. If they both decide to stick with each other, then they are coupled up. They're both coupled up, right? But they're coupled up and they're taking a risk. So they're coupled, but they're risked. It's a risked couple. It's a chance. So. But potentially a much greater chance of winning, right? You know, a risk, but a chance of winning. If Callum decides to change to somebody new, right, and Shauna decided to stick, that's what happened. Then Callum is a guaranteed couple. It's a couple, and it's a guaranteed couple, right? And Shauna is now single. Her chances of winning are much, much lower. Her chances of winning the competition are much lower. And this is exactly the same if Callum decided to stick and Shauna decides to change. Then Callum would be single and Shauna would be coupled and she would be guaranteed. Now, if they both decide to couple up with someone new, then they're both in a position where they're in a couple, guaranteed couple, but they're in a weaker position, right? They're in a slightly weaker position. So let's kind of have a look at this when we think about and this is taking the idea that the priority is potentially not to necessarily find love, but maybe to win a prize and get to the final. So Callum and Shauna, they have a choice. Can they stick or do they move to someone new? Well, if Shauna decides to stick, then Callum has a choice. He can either stick or he's guaranteed. And remember that guaranteed couple is more desirable than a couple that's a risk, right? So therefore this is the better payoff for him, right? The couple guaranteed is a better payoff. He can see that that's going to happen, it's guaranteed. And again, if she decides to pick someone new, then he has a choice. Either he's going to be single, which is kind of the worst place to be, or he's going to be a couple with a guaranteed couple where it's weaker. Well, this is better. So therefore, his dominant strategy should be to pick a new partner, right? And Sean is in the exact same position. So again, remember that we're looking at this here because it has the second one. So if Callum decides to stick, well then she has a choice. If she sticks, then if she also sticks, then they're a couple, but it's risky. She doesn't know who's going to do that. Or she can get a new couple and it's guaranteed. Well, the guarantee is higher, it's better off than the risk, so she'll pick a new. Or if he picks somebody new, then she is going to either be single or a guaranteed couple, but weaker. Well, a guaranteed couple that's weaker is higher than single, and therefore, if they are aiming to win the game and rather than actually find love or whatever else they do in there, this is their best bet, right? This is their dominant strategy. Pick somebody new, guaranteed, and this is their tacit collusion. But it's not the best place for them to be overall. The best place for them to be is here, both of them to stick. The general public loves a couple that kind of sticks through it all. But the only way they're guaranteed to get to this is for what to happen? Well, for them to talk, for them to overtly make a decision to be able to stick together. But even then, there's a risk, right? There's this incentive to move to picking somebody new, right? So for them to get to this position, they need to overtly collude, right? So this is where we see it in life, right? This is kind of just some really general examples. Game theory comes up all the time. You'll often see something and you can be like, hey, that's actually an example of game theory. If you're like me, it's a great conversation starter. So we're going to have a look at it, how it comes up in economics, and we're also going to use some examples of how you can kind of use, if you're getting confused by just having these next to each other, some ways that I see students do this. So in economics, how does this come up, or where does this come up? Where does that kind of theory take us and is relevant in economics? So one of the ways is to do with firms deciding whether or not they want to pass costs on to consumers or whether they want to stick with the prices that they've set already. So that might be an example of kind of economies of scale in an entire, like external economies of scale. So if the price of something falls that's equal to everybody in the market, well then firms have a choice as to whether or not to keep prices the same or to pass on that saving to consumers and lower their prices. So I've just got an example here. I've got Yeezy and Ivy Park, two firms that make kind of sportswear. We'll look at trainers for this example. So they both make trainers. If the price of suede or a certain material that they use it fell for both of them, then they make a decision as to whether or not to keep their prices higher or to pass on that to the consumer. Now, I'm going to show you one way that that students kind of manipulate game theory to make it easier for themselves so that they don't get mixed up. And one of the ways you can do that is just by cutting it in half, like this. Right? And then you just put one half of this box is for the left-hand side. So the reason I've put A and B here, and I've also put A and B here, is because personally I just put A and B and then assign a firm, and then I know that A is always the first one, B is always the second one, A is always the first one, B is always the second one. But you can do this so the lower left is always the left-hand side and the upper right is always the upper right-hand side. So that's absolutely fine. You're not going to lose any marks for that in any way, shape or form. Like, we want it to be as easy as for you. So what I suggest you do is you pause the video and you think about what's going to happen for these firms in each one of these decisions based on what the other person is doing, and then we'll go through it together. Okay, pause. So let's have a look and let's have a think about it. So if Ivy Park decides to keep her prices high, if Beyonce decides to keep her prices high for trainers and not pass that on to consumers, then obviously if Yeezy also decides to do that, then they're going to make more money because they're just going to make that fall in kind of say in costs is just going to add to their supernormal profit. You can see that on the diagram. If the AC falls, then the supernormal profit just grows. Or even if the MC falls, they decide to not pass on, then they'll still have more supernormal profit. So therefore, both of them will have very high profits, let's say 15 million each. Now remember, the way that I've done this is bottom left Ivy Park, top right Yeezy. But if Yeezy decides to keep their prices really high and Ivy Park decide to lower their prices, what's going to happen in the market? Well, all of the customers who were with Yeezy are going to move to Ivy Park, right? Because they will switch, because they might be homogenous, they might be like differentiated, but they're still relatively homogenous. Now, they're not all going to move because there's some irrational consumer behaviour and lots of people might like Yeezy, but there's definitely going to be an impact, right? So if Yeezy keep it the same, but Ivy Park decide to lower it, well, Ivy Park might end up with 20 million and Yeezy might end up with 10 million, right? And then obviously that's the same if it was the other way around. So if Ivy Park decided to keep their prices high and Yeezy decided to pass that on and reduce their prices, well then Ivy Park would end up with 10 and Yeezy would end up with 20, right? So, well, what happens if they both decide to lower their prices, right? Well, if they both decide to lower their prices, well, then they'll both be worse off, right? So, like, they'll both end up being worse off. So what will happen? Like, where will they end up? Well, they'll both end up kind of making less profits, but not as bad as if one of them, like if they lost all of their customers, because they're not, if they both lower their position, they're not going to lose any customers to the other one, they're just going to lose some of their profit, right? So therefore they may well end up making 12 each. So then again here, you just need to think about, well, where are they going to end up? Like, where are they naturally going to end up? Well, then we just look at the payoff as always, right? So Ivy Park makes her decision actually based off Yeezy rather than her own decision, right? So she has a choice, either she keeps or she lowers. Well, if Yeezy decides to keep, she can either make 15 or she can make 20. Well, which one's better? She wants to make 20, so she's going to lower, right? But if Yeezy decides to lower, well, then she also faces the same decision. If she keeps hers, she gets 10. If she lowers hers, then she gets 12. Well, 12 is better than 10. So in either scenario, it doesn't matter what Yeezy does, she's better off lowering her prices. Again, it's a dominant strategy, right? This is what she will choose to do. And then the exact same with Yeezy. So he has the decision. If she decides to keep it, well, he can either keep it or he can lower it. Well, 15 and 20, 20 is better than 15, he'll stick to 20. And then what about here? Either he lowers, if Beyonce is going to lower, then Kanye West has a choice of either keeping or lower. Well, 10 and 12, 12 is much higher than 10, so she will also have a dominant strategy of lowering, and they will end up here. So this is their tacit position. It's also what we call a Nash equilibrium. So Nash was an economist that looked at game theory, and he looked at what we call now Nash equilibriums, which basically is where both players in the kind of game, is what he calls it, are satisfied and they will not deviate from this position, right? So basically what you're saying is Ivy Park is not going to deviate from this position here, and we can see that that's true because she's not going to want 10 over 12, right? And Yeezy is not going to deviate as well because he's in the exact same position. So tacit collusion is also what we call the Nash equilibrium. The Nash equilibrium, it's not, you don't need to know it, but if you do write about it in your exam, if you say that this is the Nash equilibrium, then you will get the marks. That's absolutely fine. It's very commonly known. And just for your own kind of research, if you do want to look at John Nash and look at his paper, it is available on Core online, so just core.org, right? So Core Econ. And you can have a look at, I think it's called corecon.org or .co.uk, you'll find it. But you can actually read the PhD proposal that he put in the dissertation. It's really good. However, this is the best position for them on the game theory matrix. So this is actually their overt, because we know that to get to this position, what has to happen? Well, they have to talk and make a decision. But again, this is an overt collusion. Like, this happens. Price fixing is real. It's illegal, but it happens. There have been lots of investigations and companies that have been caught price fixing, engaging in collusive behaviour, overt collusion. I think it was at Asda and Tesco's a long time ago, probably about 4 or 5, 6 years ago, I think actually, about price fixing petrol prices in their petrol stations. So it happens quite often, but it is a weak position because look, once they get to that overt position, there is an incentive for one of them to move, right? There is an incentive for one of them to move and to break that collusion and to cheat, so to cheat out of that collusion.